a look at spherical mirrors. Specifically, we're going to take a look at concave mirrors in this section. We are going to do an introduction though, so you'll see a little bit of everything. So first, in this chapter or in this section, we're going to deal with spherical mirrors. So mirrors that can come from basically a spherical object. So if you think of a spherical shell where the outside is all glass, kind of like an orb, if we were to take out a section of that, right, that's where we're going to get our mirrors from. And we're going to deal with two kinds of mirrors in this section. So we're going to deal with concave or converging and convex or diverging mirrors. All right, and the difference between the two is essentially which side is reflective. And so the first kind that we have over here, okay, this is our concave, okay, or converging mirror. And so the reason we call it that is as light rays come in parallel, they all converge to a single point that we call the focal point. Right, this point right here is called the focal point. And it's called the focal point because that's where everything focuses to. On the other hand, over here we have our convex, okay, or diverging mirror. And what happens here is as the light goes towards the outside of this shell, the outside is reflective, you can think of it as this part, all the rays are reflected outwards. And you'll see that if we use our extension rays, right, and this is just a reminder, an extension ray is where your eye thinks the image is coming from, where that light is coming from. To the human eye, it would look like, oh, it's coming from inside the mirror, although we know that's not true, that's virtual. Right, the extension ray shows us that this also has a focal point, but the focal point is in the virtual realm. All right, something true to both of these is since they come from a spherical mirror, they have this thing, and I'll draw another mirror up here. Let's say that we have this line, okay, and this line is called the principal axis. Right, it just runs through the middle of our mirror. And we have our focal point, this F, where all the rays go. There's a point called C, okay, which is our radius of curvature. Okay, radius of curvature. And C is just equal to F. It's twice the focal point, at least for this course. Of course, there are caveats, not completely true. For example, spherical aberration is a perfect example of when that's not true. So parabolic mirrors we're not going to deal with so much. We're going to deal mostly in the realm of small spherical mirrors. However, both of these exist in real life. This is often used to heat up like a pipe full of water or something like that. You have to picture this in 3D. It continues on and it curves this way, and a pipe would run down the center of this thing. But these are the two we're going to deal with. And you can see that in a small spherical mirror, okay, everything goes to this single focal point, whereas a large spherical mirror, you have a lot of focal points that this travels through, right? As it goes in, it depends where it's hitting on this radius of curvature. And what ends up happening is you wind up getting this blurred focus. And this blurred focus is what we call spherical aberration. It's where your rays don't line up, right? Sometimes you want this, okay, on a flashlight if you're trying to spread the light out, but not diverge it entirely. You still want it to go to a single point, but the blurriness is better, right? Unlike a situation like a laser where you really want that light to be all together, otherwise known as culminated light. All right, so we're going to deal with the small spherical mirror and say that spherical aberration doesn't happen in our cases. All right, so there are, excuse me, 3 rules that we are going to follow for this section in terms of drawing our images, trying to figure out what our images look like. And so you're always going to have an object you should have a curvature, radius of curvature, and you should have a focal point. Remember, C is just 2f. All right, and then you also have this principal axis. Okay, all three of these are the same. There's three rules we're going to follow. And so the first rule, okay, is going to be when the light ray comes out parallel to the principal axis. Okay, in that case, it's just going to run straight to the mirror, at which point, once it hits the mirror, all right, it's going to be reflected through, through the focal point. So you got to take your ruler and line up, not take your ray, take your ruler, line up the ruler and the intersection of your oncoming ray and the focal point. All right, and then you just draw your reflected ray. And so that's the first rule. Okay, the first rule is parallel rays are going to be reflected through your focal point. Okay, parallel ray reflected through your focal point. All right. Likewise, that actually works the other way around as well. So the next rule is if it goes through your focal point, okay, if you line it up, you draw a ray through your focal point, it's going to be reflected parallel. If your ruler works. I have a dysfunctional ruler apparently. Right? So this is through F, okay, through your focal point, it'll be reflected parallel to the principal axis. Okay, PA is your principal axis. So that's your first two, 1 and 2. And now the third rule, okay, is actually the simplest of all three, is if it goes through your radius of curvature, right? And I always do the top of the arrow just because it's easiest essentially. Now you'll see, in this case, our drawing doesn't quite line up with the mirror. That's okay because, all right, as it goes through C, hits the mirror, it's just going to come right back. So it goes through C. It's just reflected back. Right, you'll notice in all three of these cases, these can all properly reflect back. So they're all on the real side of this, which tells us this is going to form a real image. Okay, this is something we're going to be able to project. It doesn't live in the virtual world off to the right of these mirrors. They're within the actual mirror. Now, when you're solving these, you're going to want to use at least 2 of these rays. In order to see your image. All right, now these are just for the concave or the converging mirror. All right, we'll come back next time and we'll take a look at examples of this. And then we'll also take a look at some diverging stuff in the future. But before we go, let's just make sure that you were paying attention. All right, a ray of light strikes a concave mirror, okay, or converging mirror, parallel to the central axis. All right, which of the following represents the reflected ray? All right, so actually, this is incorrect. It should not say parallel to the central axis because that's not what it's doing. It goes through F. All right, so a ray of light strikes a concave mirror that's going through F. Which of the following is going to be the reflected ray? It's going to be A, B, C, or D. All right, the answer is it will be A. Right? If it goes through F, it'll come back out parallel. Right? And the vice versa, if it comes in parallel, it'll go back through F. All right, till next time.